Welcome to our video. We are now exploring how do we find domain of a function in the simplest possible way with the help of 9 examples. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss how do we find domain of a function. We are going to use very simple strategy and make it absolutely simple for you to understand the complete concept. For that, we have 9 examples in this particular video. Let's begin with them one by one. Question number 1. P of x equals to x plus 1 over x minus 1. How do we find domain of this particular function? We know that the concept is that we cannot divide by 0, right? So division by 0 is not valid. And that means that denominator cannot be 0. That means x minus 1 is not equal to 0 or x is not equal to 0. So domain basically is what all values can x take in a function. So in this particular case, you can say that domain of this function is what? Well, domain written in curly brackets, we can say x belongs to real numbers where x is not equal to 1, right? So except for 1, x can have all the values in the domain of real numbers. And therefore, the domain of this function is x belongs to real numbers where x is not equal to 1. Question number 2, we've taken a square root function. And in any square root function, you know that the argument in this case is 2x plus 6 that should be greater than equal to 0. And therefore, we can now equate this 2x plus 6 as greater than equal to 0 to find what values can x take. So solving this inequality, we get 2x greater than equal to minus 6 or x is greater than equal to minus 6 by 2, which we can write as x is greater than equal to minus 3. And therefore, the domain of this function can be written as within curly brackets, as I'm saying, x belongs to the set of real numbers where x is greater than equal to minus 3. Makes sense, right? So we have learned two critical functions. Now let's take up the next question. This time we have a function r of x, square root of x squared minus x plus 6. How do we find domain of this function? Well, we know within the radical, whatever we have, that should be greater than equal to 0. So what we can do is find the zeros of this particular function. To find the zeros, you can use quadratic formula. Perfect. Find the zeros and then figure out what should be the domain of this particular function. Clear? Well, those of you who want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, joining the best universities. We can be part of your success story. Right. So, as I said, we can find the roots of this quadratic equation using the formula. So, the formula, as you know, is x equals to minus b plus minus square root b square minus 4ac divided by 2a. So, in this case, it will be x equals to 1 plus or minus square root of 1 square minus 1 square, right? So, minus b gave me 1. So let me write 1 minus 1 square, right? Minus 4ac, 4 times a being 1 and c being 6. Divide by 2 times a, which is 1. So that gives you 1 plus minus square root of 1 minus 24 over 2. And this is 1 plus minus square root of minus 23 over 2, right? So that means we'll end up with a situation where there are no real roots. And as you can see, this parabola opens upwards with no real roots. We do have a minimum value which is positive. And therefore, we can conclude that the domain here will be that x belongs to real numbers, correct? So there are no restrictions for this particular function. So as you can see, we could have a square root function without any restrictions as we saw here, right? Correct. Let's move forward and take up the next question, which is s of x equals to x over square root of x minus 2. Now, how do you work this out? Well, first thing is that the denominator should not be equal to 0, right? So that means square root of x is not equal to 2. When we square it, we get x is not equal to 4. Correct. So x should not be equal to 4 because if I put x as 4, we are effectively dividing by 0, which is not permitted. So that is one part. And second is square root of x, right? So if we have square root of x, we know that x has to be greater than 0. And therefore, now we can write down the domain, right? So you can pause the video, write down the domain. So domain for this function is what? Well, clearly it is x belongs to real numbers, and the condition here is that x is greater than 0. However, x is not equal to 4. Important, correct? So that is how we are going to write the domain of this particular function. I hope it is absolutely clear. Right. So we have taken wide variety of examples with just these functions, right? Great. Question number 5 here is r of x equals to 2x over x squared plus 1. So x squared plus 1 should not be equal to 0, right? So that means x squared should not be equal to minus 1. Now we know square is always positive. So there are no restrictions, right? So we can say there are no restrictions. Perfect. And therefore, in this case, we have a domain which is x belongs to set of real numbers. Perfect. Move on to the next question, which is we have function u of x equals to x plus 1 over square root of x squared minus 1. So there are two conditions here. One is that x squared minus 1 should not be equal to 0. Right? So that gives us x squared is not equal to 1, or x is not equal to what? Well, square root of 1 but with plus and minus signs. So remember this, x is not equal to plus or minus 1. This is one part, right? Now the second part to this is that since x squared minus 1 is within square root, we have x squared minus 1 that should be greater than 0, right? This is another part. So we need to solve this inequality that x squared minus 1 is greater than 0. That means x squared is greater than 1. And when you do square root, right? So when you do square root both sides, you can also understand the square root of x squared is absolute value of x, right? So we have absolute value of x will be greater than 1. That means x is less than minus 1 or x is greater than 1. You get the idea. Absolute value of x is greater than 1. Correct? So on a number line, we could actually show this solution as left side of minus 1 and right side of 1. You get the idea? So that's one way of showing it. The other way is you could write the domain as we had been writing, correct? So we say x belongs to set of real numbers where x is less than minus 1 union, or you can use the term or x is greater than 1. Makes sense. So that is how we can write domain of this particular function. So I hope this is absolutely clear. Perfect. You can also sketch the denominator and then figure it out. I'll leave that part to you. Now let's move on to the next question. I hope you are enjoying this journey of learning. I'd like you to pause and answer this question yourself with the knowledge gained. While in case you want to learn directly from me, feel free to send an email on globalmathinstitute at gmail.com. We have students from many different countries, and these online classes are helping them to succeed. Okay, so here we have u of x equals to 1 over square root of minus x squared plus 4. So now we want this minus x squared plus 4 should be greater than 0. It cannot be 0, right? Great. So that basically means that 4 is greater than x squared, right? Or you can say x squared is less than 4. Means absolute value when we do square root, right? Square root of x squared, right? Is less than square root of 4. We can say from here, as we did last time, that absolute value of x is less than 2. Perfect. So on a number line, you can show the solution as wholes here at 2 and minus 2, right? And within that interval. You can also write this as x belongs to set of real numbers where x is between minus 2 and 2 as an inequality. So I've shown you domain on a number line and as an inequality. Perfect. Well, some of you, as I was saying, could also sketch x squared plus 4 minus x squared plus 4, right? So let me just sketch that graph also for you. Minus means the parabola is going to open downwards and go maximum till square root of 4, right? And so here, these are the 2 points. You see that? At which we have zeros, and it is positive only in this interval, correct? So the domain is from minus 2 to 2. This is the graph of minus x squared plus 4. Perfect. So these are different ways of visualizing the function and then writing the domain. So we have learned a couple of things and different ways of writing the domain of a function. Great. Now here we have question number 8 where we are talking about a trigonometric function. So some of you might not have done trigonometric functions so far, but it is same concept. So denominator cannot be 0. So we'll write sine x is not equal to 0. Let us graph sine function and explore where are the zeros for sine x. So here's the sine function, and as you know, the zeros will be at 0, pi, 2 pi, or you can say in general, we have zeros at x equals to n pi, right? Where n belongs to integers. So those are the zeros, right? These are the zeros. Well, if you're working in degrees, then these zeros are at 180 degrees, 360 degrees, and so on. So you could also write in degrees, we can write x equals to n times 180 degrees, correct? So those are the places where the sine function is 0. So when you write the domain, in that case, you can write the domain as x belongs to real numbers where x is not equal to n times. In degrees, it will be 180 degrees. Or if you're working in radians, x belongs to real numbers where x is not equal to n pi, correct? So that is how we can write the domain of this function. Great. The last example here is based on logarithmic function. Some of the students might be working on this at present. So in logarithmic functions, we know that the argument should be greater than 0. So therefore, x minus 3 should be greater than 0 or x is greater than 3. And therefore, the domain can now be written as what? X belongs to set of real numbers. So sometimes I write two lines here for set of real numbers. One also works where x is greater than 3, correct? So that's how you write the domain of these functions. So with that, we have come to an end of our solution to all these examples. So that gives you a wide variety of examples to work with. In our playlist, you'll find many others, including piecewise functions and composite functions. I hope you have understood the concept. Explore more of my videos to know more. Thanks for your time and all the best.